Not only is it moving forward, but it's moving forward farther each time. Acceleration. So the goal is to measure that acceleration. So the data today, well, you have to measure the mass. So ray or louder. Actually, the mass shouldn't factor into this. But it's good data to have. Yeah, because there's no M there. But the way your math. So what you're going to do is you're going to get a sheet of, you're going to get your tape, and then you've got all your dots on it, and you'll like lay it down here on this table, and you got these long meter sticks. And what I want you to do is, the whole time today, call this direction, whichever direction you're sliding in for the first experiment, call that the positive direction. That'll be positive for the whole experiment today. So you're going to get your dots that look like this, and they get farther and farther apart from each other. Okay? I want you to call this 0, x equals 0. And then I want you to lay your ruler down. Center, and measure the location of all those dots. So you're going to get a table of data, which you can see it on Canvas. Like 0.1. For however many, get as many points as you can. 2, 3, 4, 5, 6, blah, blah, blah. So this is the position. Maybe it's like 0, then like 0.1 centimeters, then like maybe 0.3 centimeters, then maybe like 2 centimeters or something. Okay, that's the actual position that you measured with respect to some 0 in the positive direction. Then you've got a delta x, which we're going to define as the difference between every other position. Okay? So this guy, maybe you'll put him here. This guy is this minus this. It's x3 minus x1. This guy would be x4 minus x2. So this table of data right here is like x 3 minus x1, then x4 minus x2, then x5 minus x3, right? Then x6 minus x, etc. That's what goes in there. So those are your displacements. Okay. But we want to get velocities. Why do we want to get velocities? I'll show you. So then you got to have another column that are called average velocities. And they're going to be your delta x's divided by delta t. So this is delta x like 3, 1 divided by delta t. This is delta x 4, 2 divided by delta t. This is delta x 5, 3 divided by 3. All you're doing is doing displacements divided by time. And the delta t is the same each time because it's 2 of these, and each one of these is clicking. Remember, this thing is clicking 10 times a second. So every click is 0.1 seconds. But this is 2 of these. So your delta t here is going to be 0.2 seconds for everybody, for the whole experiment. So you don't need to calculate anything there. It's just delta t is equal to 0.2 seconds. So you're going to take whatever this displacement is, like 0.3 minus 0.1 divided by 0.2 seconds. x4 minus x2 divided by 0.2 seconds, etc., etc., etc. Those will give you, in centimeters per second, that will be the units that they use. Those will give you average velocities at each instant. They will give you like an average velocity. Then you're going to plot, when you get to the point where you're making the graph, you're going to plot average velocity as a function of time, which is just each one of these. Okay? And each one of these is 0.2 seconds apart, right? Okay. 0.2, 0.4, 0.6, 0.8. Okay, you'll plot it like in Excel. Like this for 0, maybe 0, 0.2, 0.4. Like that'll be the data that you plot. All the way for however many points you have. This is in seconds. And you should see your velocity, your average velocity, like increase from rest. And it'll be maybe a little noisy, okay? It's not going to be like a perfect line. So you take the data, you plot the data, then you're going to tell Excel to find the fit. So Excel is going to find a linear fit to your data. And then you're going to say, put trend line on graph. And it's going to put a trend line on the graph. Excel's going to be like, this is the best fit through your data, like a linear fit. What is the slope of a velocity versus time graph? What did we just find? Acceleration. So here's the experimental value. So that's the theory, and here's your experiment to see if it's true. You're going to find the slope of your data of a velocity versus time graph. So whatever Excel tells you this is, whatever line that is, find the slope of that. So this is going to come up as y is equal to mx plus b type form, okay? You need to grab this guy. That's not max. That's the slope, right, from math world, okay? This should be g sine theta. Okay? So how do you know how good your experiment was? You're going to find the percent difference. And that's going to be actual minus theoretical divided by theoretical. So this is your actual value. And then you're going to subtract from that the theory. Divided by the theory. This right here is just a number that you grab from Excel. This whole thing. It's just one number that you just put in. This you calculate, this you calculate, and then multiply times 100%. Okay? Then, once you do that, and this will take a while, but then there's the second part of the experiment where you do the same thing, except now, the ramp, same tilt, don't change the tilt, don't change that. But you're going to use this as still positive. What we're going to do is you're going to take your rider with the air on and you're going to give it a push. Okay. But we would expect that these forces have not changed, once you let go of the rider. The acceleration should be the same and in the same direction. It should still be this like 9.8 meters per second squared positive from this in the positive direction. So your tape now is going to look different. Well, from a certain perspective, it's going to look different than another perspective. It's going to look exactly the same as this. Because now you're starting fast. So your dots are really far apart from each other. But then they get smaller and closer to each other. So it's going to look just like this. Okay? But what I want you to do now is measure, well, the same way. So you've got this. Still call this x equals 0. But when you measure, and you measure from 0, this is your x1, this is your x2, this is your x3, this is your x4. Now you're going backwards, okay? So now x3 minus x1 is going to give you a negative value. And x4 minus x2 is going to give you a negative value. And these are all going to give you negative average velocities. So what your graph is going to look like, and what you should expect it to look like in part 2, is large negative velocities that are getting smaller. So something that looks like this until they're like at 0. And then you do the same fit, and you should find the same slope. It's just that now your velocities are in the negative range. So the only things you need to remember, and I don't really think you need to weigh the thing, but if you're curious, you can weigh it. And I wrote it. Just remember to
have one person do each job. Don't have, like I was doing, like one person do everything. Only put a cart on the rider if the air is on. Communicate with the people across from you because you're both using the same air supply. And don't touch the wires when someone is pressing the button. That should be it. That should be good. I think you guys are good. All right. Good luck. Have fun.